All right, peeps, here we go. We're going to learn how to graph equations today, and we're going to use all of our prior knowledge about slope-intercept form and slope being m and b being y-intercept to graph equations. So what's going to happen is they're going to give us an equation, for example, y equals 3x. Sorry, my pen's not working great today. Plus 2 and we're going to determine first, is this equation in y equals mx plus b form? Yes, it is, but if it weren't, then you would need to make it in this form before you could continue. The next thing that I have to do is determine what the y-intercept is. Well, I know that b represents my y-intercept, and in this equation it happens to be 2. And that if I had a graph, I could go ahead and find 2 on the y-line. We'll say it's probably about here. And I could plot a point there. And that would be my y-intercept, which means that's where my line is going to cross the y-line. The next thing I need to do is determine what the slope is. And I know that slope is represented by m. And in this case, it happens to be 3. Now, when we're graphing equations, we need the slope to always be in a fraction form. Now, you know that if you have this kind of a number where it's just plain old 3, that you can make it a fraction by putting a 1 underneath it. Now, we do this because we need to know what the rise is and what the run is. Remember, we like to use rise over run for when we use graphs. So we need to know rise and run. So what we're going to do is we go to our y-intercept point and we do what it tells us. We rise 3, 1, 2, 3, and we run 1, and we plot another point. And then we can connect those points to make a graph of a line. Sorry, I don't have a ruler, so it's not really quite as straight as I'd like it to be, but you get the idea. So there's just some things I need you to know. If it's a positive slope, then our rise goes up. However, if we have a negative slope, then our rise goes down. And of course you know that the positive slopes, they go like this, and the negative slopes, they go like that. So if you had 2, and then your slope was 3, you went 1, 2, 3, and over 1, that would make sense. If it was negative 3 slope, you would start at your 2 and you go down 3 and over 1. So it would go in the negative direction. And we're going to do one of those so you'll be able to see that. So please make sure that you have all of this stuff in your notes. If you did not get a notes sheet from me and you want one to do this video, you can go to the snow days on my calendar and you can print one out. There are some attached there. All right, so the first thing I did was I went ahead and I drew my x and y axis on my graph paper. By the way, as I've been saying a lot lately, you need graph paper. So please make sure that you come in with graph paper tomorrow. All right, so the first thing I need to do is make sure this is in y equals mx plus b form, and I've got y equals mx plus b, so that works. My next step is to determine what my y-intercept is, which is represented by b, and in this equation it's 1. My next step is to graph this, to plot a point at my y-intercept. So I go to my y-line, that's my vertical line here, and I find 1 on my y-line, which is right here, and I put a point there. Next, I determine what my slope is. And in this equation, it's 2/3 represented by m. And I know that the 2 tells me my rise, and the 3 tells me my run. And that's a positive slope, so my rise is going to go up. So I'm going to start right here at that point that I just plotted for my y-intercept. And I'm going to rise 2, so 1, 2, and I'm going to run 3, 1, 2, 3. I'm going to plot a point. And if my graph paper allows, I can do another point just so I can have several points to graph to connect the dots and make it prettier. So I can do the same thing. I can rise 2, 1, 2, and I can run 3, 1, 2, 3. And I can go ahead and connect those dots. My lines are awful on this program, sorry. And I have a nice little line there. Now check this out. I've got 2 triangles here. Look at that. I've got one there, and I've got one there. And they both have the same slope. So you can tell if similar triangles, if you have triangles, they're similar if they have the same slope. So if ever you see a question where it has the triangles like this, if you know they've got the same slope, then they are definitely similar triangles. All right, moving on. That's just a little extra piece of information for you. Graph the line of the equation y equals 2x minus 1. The first step is to determine, is this in y equals mx plus b form? So y equals mx plus b, yes it is. My next step is to determine what is my y-intercept, represented by b. In this equation, it's -1. My next step is to graph that. So I go to my y line, and I'm going to find -1, which is here. I'm going to plot that point. Next, I need to determine what my slope is. For this equation, it's represented by m, it's 2. And because I need it in fraction form, I'm going to go ahead and put that 1 underneath it so that I know my rise and my run. And that's a positive slope there, so I'm going to go up with my rise. So I'm going to go up 2, rise 2, I'm going to run 1. I'm going to rise 2, I'm going to run 1. And really I can just keep doing this until my paper runs out. Rise 2 and run 1, rise 2 and run 1. And the reason I like to make so many points is because it makes them easier to connect, especially when I don't have a ruler. So this line is represented by y equals 2x minus 1. If you want to label the line, that's perfect. Okay, our next example is going to be graph the line of the equation 2x plus y equals 3x plus 1. This is not in y equals mx plus b form, so I need to get that y alone right there. So I'm going to subtract 2x from both sides. Those cancel out. I have y on that side. These are like terms because they've got that variable of x attached. So I can go ahead and combine them. 3 minus 2x is 1x. And then that is not a like term with x. There is no x attached to it, so I just bring that down. And my next step is to determine what is the y-intercept, represented by b in this equation, happens to be a positive 1. I'm going to graph that positive 1 right there. And my next step is to determine what is my slope, and in this equation it's a positive 1. And of course I need it to be in fraction form, so I put the 1 underneath to determine my rise and my run. And that's a positive slope. It's positive, so that's going to go up. So I'm going to rise 1 and run 1, plot a point. Rise 1, run 1, plot a point. Rise 1, run 1, plot a point. Try saying that 50 times fast. And I can go ahead and connect those points. And that would continue down that way too. And of course, you know, it's really easy if you have your ruler or some kind of straight edge to just line up to those dots and trace your line all the way through. Makes it so much easier. So this is y equals x plus 1. My last example is graph the equation of x plus 2y equals 4. This is not in slope-intercept form, so I need to make that happen. I need to get that y by itself, so the first thing I'm going to do is subtract x from both sides. Whoops. And those x's cancel out, leaving me with 2y. And these are not like terms, so I can't combine them. So I just have a negative x and a positive 4. Y is still not by itself, so I need to divide by 2, and I'm going to divide everything by 2. That leaves me with y equals. Of course, you know, if you don't see a number next to a variable, you automatically assume there's a 1 there. So I have negative 1/2 x, and then 4 divided by 2 is 2, and that's a positive. Now I've got it in slope-intercept form, so I can say my y-intercept represented by b in the equation is a positive 2. And I can plot that positive 2. Right there. And my slope is a negative 1/2 in that equation. So that's going to be my rise and my run. And because the slope is negative, that means that my rise is going to go down. So I'm going to go down 1, and I'm going to run 2. I'm going to go down 1 and run 2. I'm going to go down 1, I'm going to run 2. I'm going to go down 1 and run 2. I'm going to go down 1 and run 2. And my line's going to look like that. And that's represented by y equals negative 1/2 x plus 2. Okay, easy enough. So we're going to do some more of these tomorrow in class. So please make sure that you have your notes present with you. Of course, you know if you don't have them. And, oh, Ms. Arsenal, I did it at home and left it at home. Well, you can't prove that if you don't have it with you. So please bring your proof that you did it at home. If you have any questions, please come prepared with them. And I hope you have a great rest of the weekend.